Hello, welcome to another video. In this one, we're going to talk about a feature that was perhaps accidentally landed in 3.11. It's not actually called out anywhere, and the PEP says it's supposed to show up in 3.12, but it appears to already be there. Anyway, let's jump into it. Okay, so for those of you that have played around with the garbage collector module a little bit, or any sort of ref counting stuff, you'll know that there's a sys.getRefCount function in the sys module. Oops, I forgot to print it. And you can pass objects into it, and it'll tell you their reference count. For instance, the number 0 in a pretty empty interpreter is referenced 226 times. None is another thing that gets referenced quite a lot. Any function that doesn't return a value is going to return none. That's part of the constants. Anyway, you get the idea. There's a lot of objects in Python that have reference counts, and you can query them from this. But if you look at 3.11 for some of these objects, the reference count is extremely large. There's definitely not this many objects referencing this, so something weird is going on here. And it turns out this is a leaking implementation detail of what's referred to as immortal objects, which is supposed to land in 3.12. However, there are a few immortal objects that are already present in Python 3.11. Notably, one character and empty bytes, I think Unicode? Yeah, and one character and empty Unicode objects, as well as some of numbers up to 255, I think. No, even higher. Okay, up to 256. So there are a few objects which have historically been always sort of globally initialized at the beginning of the Python interpreter that are now what are considered immortal objects. And these objects have an extremely high reference count, and the idea behind immortal objects is that these will be truly immutable objects. They won't participate in reference counting, so they won't influence copy on write or other stuff like that. Also, the garbage collector can skip them, and generally your program won't have to increase and decrease the reference count of none a whole bunch, which is what happens today in Python. There's some talk, most of this is around, not invalidating the CPU cache by doing writes. There's some ideas of sharing these global singletons between a bunch of interpreter instances, such that you could have true singletons that are immutable and share them across interpreters. There's also this copy on write, which I did a video on before. Actually, I did 2 videos on. I will link those in the description, etc., etc. But basically what happened is Python is now marking some objects as immortal with a special bit inside the reference count variable. Now, they didn't want to make the Python object bigger, put another flag in there. So they're abusing a high order bit of the reference count to mark that this is an immortal object. And so that's why we get these fairly large numbers here that are not actually, there aren't actually, 1,000, million, there aren't a billion things referencing the number 1. So this is the way of marking it as immortal. But anyway, that's immortal objects. Hopefully this will make it so you can have truly immutable things, and then copy and write will work better in Python, and there'll be a whole bunch of other micro benefits out of this as well. But anyway, that's why you might see extremely large reference counts in Python 3.11. Hopefully you found this useful. If there are additional things you would like me to explain, leave a comment below or reach out to me on the various platforms. But thank you all for watching, and I will see you in the next one.